because audio interfaces are pretty expensive.
Oh. So okay.
Keep talking. Just keep talking all the way.
Okay, I already start streaming. We are going to test our audio now. I'm trying to talk not too loud as sometimes it happens, but also not too quiet. Yeah, that's pretty much
Okay,
it.
increase your audio, man. Increase your audio.
Oh, okay. Try it now.
Wait, I will drop the stream.
Okay. Okay, I like changed the way my like mic volume is, like right here, and it was basically that the change that I did, just for us to test stuff on audio, and that's basically it. If not, I will have to try to mess with OBS to see if that's why it's too low my audio here.
Okay, I'm back.
It is okay?
Decrease a little bit of the volume of the bot.
Okay.
Increase my voice.
Huh?
And increases just a tiny bit my voice.
Okay.
I think it's fine, 20%.
Yeah. But how can you hear your own voice?
It's complicated. I'll be back in a few seconds.
Okay. Now I regulated also the bot volume, like it's like on 10. My is
No, the bot is too quiet now. I think that 15, 70% should be enough.
Lemus, your mic is weird a bit weird. Can you try to speak again?
That's...
Yeah, now it's normal.
Okay.
It's only
just
when you
keep
arrive.
talking now.
Okay. I will just keep talking for Lemus. See that again for like a third time to see if our audio is fucking okay. And I guess it is. It should be by now. My voice in comparison with the bot one.
The bot is 22%. Put 20% now you're done.
The bot is 17.
Oh, so go 20. Or 90.
Okay. Okay, so...
Final test.
Okay. The final test and the thing begins. And the bot's now like 21. Mine is like kind of the half. I don't know how much it is.
Fine.
It's fine?
Yeah.
Okay, nice.
Uh,
Lemus, I'm recording like the Discord part. You can like get like...
the link is already there to you to join.
Oh, I'm already there. But it's just that I will be like ordering food. And... Oh, okay. Yeah. You will just code, right? So...
Yeah, I will code for now the... at least the beginning. I'm trying to find how to manipulate strings now. That's what I'm doing.
Yeah, but hey, even though I still think it's better if you are like sharing your screen, because we will do something else besides only coding, so... Only VS Code is not enough. Okay.
Done.
Okay, nice. So okay, what do you want to do right now?
I want to be able to, like, I have a string with a bunch of characters. I want to like remove the last 3 or 4 characters at the end of the string.
Okay, I think you could transform that into like an array and then remove the last ones. Oh, nice! You can use the slices there, as in Python? I think Python has it. Yeah, you
Python,
can...
we would do something like this, I guess.
Yeah, it's not exactly the same syntax, but I think you can use a range there. The syntax for ranges.
Ranges.
Yeah, because it's just an array also, right? It's a vector of char, so you could just use like a range.
How do we do that?
Like there, you see the... Yeah, you could use this syntax to get the
but this is complicated, man, because you want to go from the end to the beginning, not the opposite. We don't know how many characters this thing has.
No, actually you can do it. Man, you just go like from 0 or just dot dot. Just don't put the 0 if you want. And then you go to n like -4. You can get the n.
Too verbose, but okay. Uh, and -4.
Yeah, I think we need parentheses there, Lance.
Okay. Like this.
Yeah, let's see if that works. Maybe they have a prettier way to do that with one method and stuff.
Oh, and I also need to recap you what exactly is already done, because I changed a few things offline.
Okay.
Let's just see if this works. So we just do encode like this, and then okay, this is not right. Compress. Oh, it's IO. Okay. IO. Compress file. This will receive the original file name, which is this, and will also receive the bit representation. But I think it's better to have just a reference for it. So it's gonna be like this actually. And so this is gonna be this, I guess. Oh, and this is also mutable because it's the same that I did here. So this is also mutable, which is fine, I guess. What are you complaining about? Expected mut unknown, but found hash map. Okay, I don't know if I got the 0.
What the fuck is that unknown, man?
Yeah, I have no idea.
Huh.
What the fuck is this, man? Durai did some. It's because it's the same name? Do you have a problem if it's the same name?
No,
Okay.
definitely not.
But hey, I want to pass this bit representation to this. The type of this is hash map string string.
Okay, let's go
But
there.
But I want to pass a reference, and it's
Hash
mutable.
Man, that's right for me.
Okay, so let me pick a terminal. Cargo run. Let's see if this works. It doesn't. Not found in this scope, which means that I need hash whatever. I need the same thing that we are using in encode, hash map here. We also need that in IO. This should be fine. Okay, so the Rust analyzer is doing something. Let's see if cargo run works.
Oh no calzones today, man. They are closed.
Okay, man, your strategy didn't work.
Okay, they are complaining about.
They are complaining about not having the copy trade apparently.
Wait, cannot move a value of type str. Huh? Not not index of str. Because the value has type str, we do not remember the copy. Great. Okay, can you go back there? What is the file? What is file name?
It's a string.
Huh.
Oh, it's because it's a reference for a string, man.
No, you don't use just str, as far as I know.
But shouldn't I have dereference this?
No, it has automatic dereference on the stuff. Fuck. He's saying something about moving.
Okay, so let's choose something a little bit less complicated, such as
No,
this.
it's not regarding the range. Well, we can try it for sure. But the problem is not really the range, I guess.
Yeah, it's not. Okay,
Yes.
you're right.
So go back to the code and let's just take a look on this error. That's...
We are on the code. This is the
No,
code.
no. Okay, the terminal. I mean.
Oh.
Okay. So he's. Oh,
Oh.
and on the score.
Oh.
Hmm?
Apparently, this range notation is classified as a move. Which will suck.
Wait. Cannot. The first one is cannot move a value of type str. The size of str cannot be statically. Oh, I think that range don't work for this str. Maybe on a
New
string.
file name. We could do something like to owned.
What is two on it? Oh, okay.
I'm stealing the property.
Huh?
Yeah, this to own I because the move is it happens when someone else has the like it's the owner of this
Mm-hmm.
and I'm trying to steal from them but I can't because because the compiler complains. And when I was doing the offline things, this error also appeared about this thing that you are trying to do is considered as a move and you cannot do that. You need to pass a reference. But then I read in a forum that in order to get around this, you can steal the ownership of a thing. So you are basically this is a way to get around the reference problem.
Yeah, that doesn't sound too good, but I'm okay with it.
No, I'm not recommending that for like serious stuff if you're doing a bunch of manipulation. But this is just for like do string manipulation with the file, so I don't care about stealing this. So considering borrowing, maybe I need to do the to owned after. Which is fine, I guess. Okay, it worked.
Oh, by
But
the
it
way.
didn't do what I wanted.
Okay, what?
I want the like we can do this just to be sure that we are not crazy. Eight. 5, 6, 7, 8. Okay, so this is correct, but the range notation is not working apparently. Oh, it's because I'm dumb. Nice. Nice. Please work. Nice, man. Nice. Now, string concatenation. How we do that?
Wait.
New file. Name.
Oh, we don't have the Discord link on Twitch, right?
We have. It's in
Do
our
we?
about page.
Oh, wait. Oh, okay. Okay, so what do you want?
I
Concatenation?
want to do a concatenation of strings.
If it is a
Oh,
string,
this worked!
what?
Nice!
What working?
Here we have our .zip.
No. What you were doing, like?
No, I was just concatenation. See? Here?
Ah! Oh my god, I didn't know you had this overload. But if it is a string, like with S, you can do like push or push str or something. Yeah, push str.
That makes sense. But this is like C style.
Doesn't mean it's good.
It's for me. It's easier to read. Okay, so next step is one of the boring steps
Okay.
because you have to. Oh, let me just recap for you first. So, like long story short, what we are doing here is the following: you have a file, right? A file name that you in the future we will pick this from the command line. So you're gonna be able to pick which file you want to compress. Then we are reading the contents of the file with the provided name. We're gonna have to do some sort of error handling in the future for this. And then we are calculating the probabilities of each element, and then these things here is just to pick the original, like the symbols that we have inside the file that we are reading. They are inside probabilities, but later we're gonna manipulate probabilities and it's gonna be empty. So in order to save the original symbols, I am doing this. I'm just making like a copy, as you can see here. Like I'm doing a for, iterating through probabilities and pushing just the symbol. I don't care about the probability, but I can't lose this. I will explain later why. And then we are creating a Huffman map with the probabilities, right? So we are using the same thing that we discussed a bunch of times, which is this picture right here, which is basically creating a tree.
Yeah.
And when we create a tree, we discover the most frequent symbols that are going on here, and then we discover the bit. We need to discover their bit representation. So this is what I did offline, by the way. These two
Okay.
lines here, I did offline. So I made this function called translate symbols and filter by symbols. Translate symbols is in here, which is a function. Yeah, it's here. It's a function that do that procedure that I told you back in the last session, I think, which is what is the representation of B? It's CB plus 1, and so on and so forth. So this translate symbols function is doing exactly that. It's traversing the hash map of probability, or the hash map that we made from the probabilities. So it's picking probabilities here, and an empty hash map. And then what we're doing is doing this procedure until we finish the entire tree. But then we're gonna have a problem, which is we don't care. Like we don't understand what is CB plus 1, right? This doesn't make sense because we want to have the bit representation. You need to like do a conversion, right? To do a conversion, this is what the translate symbols does. So it picks the tree, translates to, instead of symbols plus bits, we just translate the parent, right? Because we are considering the CB to be the parent of C and B. So we are making sure that that B is not being described anymore in terms of CB. So this is what this function does. I can go into more detail offline if you prefer.
Yeah.
But then we had another problem, which is we don't care about the representation of the imaginary symbols. We don't care about which bit representation is CB or ECB. We don't care about those. We only care about the leaves. So this is what the filter by symbols does. It picks a symbols that we want to maintain and the hash map that we just acquired from translate symbols, and basically iterates through them and filters only the ones that we want. So this is why I had to save the original ones, because these are no I need to keep. So this is what the filter does. And if you go on the terminal, are you looking at my terminal?
Yeah.
Look at this. Now we have, this is the A, the 97 is the A, the B is the 98, and the C is the 99. So now we have A is bit 1, B is bit 00, and C is bit 01.
Bit? Wait, why is it 00 and not
And not?
0?
No, but that's the thing. How many bits it matters in this particular algorithm. Like, when you are doing for instance, suppose that you are reading a file, right? And you read the first bit of the file. If you read the first bit of the file, you know that this is the byte A.
Mm.
And let's suppose that you start reading the file and you encounter a 0. If you encounter a 0, you need to read the next.
It's like 98 or 99, right?
Yeah, then you need to read the next one. And because of the Huffman tree property, it's assured that they will never have conflicts. And then we have this. So next step in today's session is to make the compressed file, which is actually what we call encoding. How you do that? There are two parts in the encoding process. We have the header. The header is actually what makes this thing works, because the header is composed of this dictionary right here that I just showed you. So we need to put this in the file, because the decoder needs to read this to know how to translate. So this is the dictionary. So the header is composed of the dictionary plus padding. Actually, how many of padding? How many of padding? What is how many of padding? Do you understand that after we translate all the file that we have with using this bit representation, maybe we're not going to have a multiple of 8?
Yes.
If that's the case, we have a problem, because it means that we're going to have to add padding to have a byte. The minimum unit that we can make a file is a byte. We don't have any sort of file that it's just bits. The minimum is a byte. So the way to do that is to add padding, which means adding zeros at the end of the bit array. But you need to inform the encoder how many bits he will be ignoring at the end of the thing. So this is the header, and then the actual content. So this is basically a map from the actual content to the bit representation. And then one thing that we need to pay attention is how we're going to put the dictionary. The dictionary is important. The dictionary is made of 3 things. The byte, which is the key. Then a middle guy, that is how many bits you're going to read. And then the bit itself. So for instance, in this particular case, we're going to have B, the byte B. So I'm going to write it like this. And then we're going to write into the file 2. And then 0, 0. Because then the decoder will know, okay, the B is the next 2 bits. The bit representation of B is the next 2 bits, which is 0, 0. And then we're going to do that in a row. So B, A, B, C. All the bytes, right? We'll follow this convention. And then after all of this, and having the content, we're going to know how many. Like we need to do a sum of the header and the bit representation. And then we're going to divide that by, like we're going to do mod 8 of this. And then we're going to know how many bits of padding to add it in the header. And this is what I'm calling .drn for obvious reasons. So this is our test.drn file. And then a decoder will pick this .drn and will transform back to a .txt.
Mm-hmm.
So that's our goal. So I want, in this today's session, to try to finish this encoding process. Because it's not as hard as what we were doing before, which is like traversing trees and things like that. This is already done, and the encoding itself, like per se, is done. The only thing that is not done is writing that into a file. So what we are doing now, we are creating a function called compressFile, which picks the original file name of the file and this dictionary that I just showed. And what we're going to be doing, we're going to first create this dictionary, which is picking the bit representation and writing into a stream the byte, the how many bits, and the bits themselves. We're going to do that with all the bit representation. It doesn't matter the order. We can do that we don't have to sort. It doesn't matter. And then, after having the header, we need to take care of mapping. And then we need to sum them and then do mod 8 to get the padding. It seems reasonable we have 1 hour and a little bit. So this is the goal for today. Is that clear?
Yeah, just one thing. Are we going to treat that part later regarding, okay, what is the file that we are receiving so we could encode this on the header? So when we are decompressing, we can actually put the correct extension and stuff?
Oh, we can do that later.
Okay.
Right now, we're going to hardcode to .txt.
Okay.
But let me like give you a warning. Huffman algorithms, they are not great for zipping anything else than text. Usually they are pretty bad with images and stuff, but we can do that just for fun.
Okay.
Okay, let's do this. So compress file. This is what we were doing before, right? So this is basically creating the the name of the new file that we're gonna create here. Okay. So I want to do, man. I don't know which module we're gonna do that, but for now we're gonna do in here a function called get dictionary header, which basically picks the bit representation. Oh, thanks. And returns. It's gonna return a vector of strings for now. Just for now. Maybe I change our minds later. And what we're gonna do? We're gonna do something that really similar to this. We're gonna iterate through the dictionary, right? In this dictionary, we have the symbol itself, like the A, the B, and the C, and then the bit representation. What you're gonna do is really easy. We're gonna just pick the bits in here, and this is gonna be, instead of hash map, will be bit representation.
Mm-hmm.
And instead of doing this if, we're also gonna have to have like a let. I don't know. Dict header, and you're gonna do vec new. It's gonna complain about types probably, so I will start typing stuff like this, and then you're gonna do first the bit representation, right? So push symbol, then the size. So it's gonna be the size of the bits, so len to string, and then finally the bit representations themselves. I think you're gonna have problems with movements here. Pretty sure. Then return. This seems reasonable.
Oh.
What do you think?
Can you repeat the for part?
Mm-hmm. We are iterating across this. So this is the left is the symbol, the key is the symbol, and the bit and the right is the bit representation. We are putting into our vector of strings the symbol. Then we are getting the size of the bit representation to know how many bits we're gonna have to read.
This is not a dict header, right? It is? It's like just a vector, so what is the dict part of this?
How can I explain that? We are expressing this dictionary as a vector. Because we are still, like, we are writing this relationship right here, man. This right here, sorry. This is still mapping to this, but there's a middle guy just to know how many bits you're gonna have to read when in the decoding process.
Okay, but does that make sense for each iteration? Like how many padding? Isn't that only for like all of those? Or is that for each character, for each scene?
No, this is important because the decoder does not know that it has 2 bits for representation. The decoder knows nothing. You have to assume the decoder knows nothing about the encoding process.
Mm-hmm.
And this is pretty common in compression algorithms. Usually the decoder doesn't know anything about the encoding process. It only knows how to read the file. And this is why usually decoding is so much easier than encoding. Because the decoder, it follows very simple rules how to read a file. The encoder is actually the more complicated part because there's a bunch of logic and stuff. For instance, just reading the file, the decoder will not know, oh, this involves binary trees and whatever the hell. No, man. The decoder only knows rules to read, how to read a file. It only knows that. But he doesn't know what we know. The encoder knows that the B requires 2 bits. But the decoder doesn't. So this is why we need to do it like this.
Okay.
Okay. So now that we have this function here, we can test it. So let me pick a print. In this line is fine. And we're gonna do get and dictionary header, and we're gonna pass the bit representation, which is fine. Let's see. We're gonna have some errors. I'm pretty sure that this a bunch of pushes will have some like move complaints or something like that. You see? But this is not movements. This is just reference stuff. Help. Try using a conversion method to string. Expected string found this. Oh, this is because of the push signature. To string. What else? Okay. This also is complaining. Nathan, if you have any questions, please ask.
Okay, I'm just ordering my food.
Oh, see? This is the problem that I was talking about. Cannot borrow as mutable. So mutation and moving stuff and borrowing stuff. This is the pain. Cannot borrow as mutable.
Okay, let me see.
So it's complaining about these guys.
Let me see, Dick Rather. Oh, but if you are pushing, it needs to be mutable, Lemos. Line 12.
Holy moly.
Line 12.
Oh, here. I'm dumb. Sorry. Can I do this?
No, you don't.
Don't need here, right?
Yeah, I don't think you do.
Okay, this is just a guess now. Of an experienced Rust programmer.
Would be so weird if you need to. Okay.
It worked. Nice. Nice. Now, man. Now we have. We just have to count. Because we already have the bit. This is the header. Okay. Just missing the padding. But to have the padding, to be able to do the padding, we need to do the mapping. So let's do that. But this is not I/O. This is encode because it's still related to encoding process. So fn map to dict. We're gonna receive what? We're gonna receive the original content. So it's gonna be content, which is probably a vec of U8s, and is also gonna receive the dictionary, which is I think is the same signature as this. And we're gonna return another vector of 8s. Oh no, this is gonna be a vector of strings because it's bits. Okay. So, first question, do we have a way to have the content? I'm a little bit worried about that. In theory, we do. We do have the file content, which is fine. Okay, so let's do that then. So let's do a for byte in content, and you're gonna also have to do mutable, so mapped content.
No. You see what you are doing, man?
What?
You are doing a map.
But do we have map? This sort of map in Lisp? In Rust?
What do you mean this sort of map?
No, do we have a dot map?
Sure.
Return content map.
No, maybe you need to transform in ether if you don't have it yet.
Oh. Oh, we do have a map. Okay, cool. The map is to pick a byte.
Man, that lambda is so weird.
Oh yeah, it's pretty weird. Um. So this is basically picking a byte and passing that to the dictionary, and that's it, I guess.
That is the interesting thing, right? Because you have a ether and you are mapping that, but what is the result of that? It's not.
Isn't like unit?
No. If you are mapping, you need to return something. The map is not mutable, right?
Oh, so this is not the same map as we use in functional programming then.
No. I think the map is not mutable, so you are returning something, right? So, but what? He's not complaining right now, right?
I don't know. I didn't try to compile, but
yeah, let's see. No, I see the VS Code is not complaining, but let's try to compile that.
Okay. Do I need to call the thing, or it's gonna compile? Try to compile anyway.
Good question.
Okay. Expected struct vec found struct map. Okay, so this is not the same map that we use in functional programming.
Okay. Now try
This
to do
is
a
a
dot
bit different.
after. Yeah, the ether part, right? Wait, we are content vec. Huh? That. Just take a look if we don't have the map on the vec instead of the ether.
And there's another problem as well.
Take a look.
We need to convert this U8 to a string, man.
Okay, like we will get there, but okay. No, just put M. Like if we don't have with M, there is no map.
Oh, and please take a look on the chat because I'm not looking at it.
Yeah, I'm taking a look.
Okay.
Lemus, first of all, you said that you are getting a U8 and you need a string, right? So
yeah,
it's the same map.
We need that back here, right?
I think so. So okay, you will do inside the map also, and keep using the ether. I think after the map result, we could do something to vec. Well, transform vec in some. Oh wait, is that it? You need to transform before checking the dict.
How we do?
Okay, then try to put like dot something.
Vec from
ether. Oh, I see. Wait, but will that work? Like,
let's see.
Huh.
I'm not entirely sure. No, okay.
But wait, he's complaining about.
Okay, so there's a trait that is missing.
Okay, just put from ether. Oh, but not sure if that will be the case because it's not an ether anymore, right? Unless.
Yeah, it's not an ether.
Unless we do the map.ether. Oh man, what a joke.
Like this?
Let's see.
Holy man. Look at this convoluted line. Thanks, Reverse Analyzer.
That's hell ugly.
Okay, I guess.
Oh, just dot ether. Without calling the function, let's see.
It's also complaining about expected reference but found struct string, which is rather interesting. Man, I think. Oh no, this is not what we want, man. This is byte. This is correct. That was correct. To access the dictionary, you actually use the reference instead of the thing itself. Oh, now it no, but this is still okay. So never mind what I said. This is still wrong.
Yeah, in there it's private field. It doesn't let us access anyway.
Oh man. Okay, so.
Oh, we have a few problems.
Okay, so let's search map to vec Rust.
Maybe you could search how to map a vector in Rust.
Oh, dot collect.
Oh, okay.
Whatever that is. But I still want to address this thing, man.
Yeah, I think maybe you don't need the vec from ether anymore.
Makes sense. But we need to convert this UA to something else, man.
Okay, let's just run this already to see if that one vanished.
Okay.
Oh, that music is really good, man.
Okay, so the trait borrow is not implemented for string.
Okay, so what the fuck is dictionary?
Wait.
Wait, why did you wrote dictionary?
Because this, look at this map to dict. It picks a content
No, no,
and
no,
uses
no.
a dictionary map.
I was expecting dict from you.
Oh.
Okay. So it's a hash
Anyway,
map. Do you really access this way?
I guess so. We can search.
Oh man, you are using
but I did
Python.
this. No, but I already did this back in the day.
It looks like you are using Python there, using the brackets to access the hash map. The hash map.
This?
Yeah.
No, but this isn't the Rust documentation.
For the hash map?
Hash map Rust.
Oh.
Look at this.
I was not expecting this. Where exactly?
No, it's not this.
Because
it's a longer post. I saw it in a longer post. No, this is the one that I went. Is this the one?
Like, if that's the case, then hashmap has a really high level.
Entry. Maybe you need to do that with entry, but I remember specifically they using with the Python notation. Maybe I'm going crazy though.
Aren't you? I don't know.
Okay, maybe I went crazy. So you need to do dot entry apparently.
Are you sure that you want the entry?
Actually, I'm not. Let's read instead of guess. Entry.
I was expecting like get or find.
No, here it is. See, this is almost Python notation.
Oh wait, but that it is on U8. Oh no. Wait. Wait, what the fuck is that? No, it's not a U8, it's not a byte. It's like reference for a char?
Yes, it's a reference for a char.
And letters, what the fuck is letter? It's a hash map.
Yeah, but you see, so there is a Python-like notation.
Okay.
But that's the thing, we need to convert, instead of being a reference to a U8, we need to make this a reference to a string.
Wait.
How can we do that?
Yeah, that's the thing that we were doing up there. UA to string. Yeah, we really want that thing. Like byte, you have.
So it's byte to string.
No, I'm not saying it's that. I'm saying it's the thing that we did up there because we did UA to string before.
No, but we did the opposite.
We did the string to U8? I don't think so.
No, we did like this, man.
Yeah, so let's use this.
I think
but
I already
I don't
tried.
think you need the I don't think you need to dereference this stuff.
Okay, so yeah, basically what it
or
was
maybe you do, right? Because there you have like.
I think I already tried the referencing. It didn't work. Doesn't work. So let me try.
Let's try both, right? If one doesn't work.
Yay!
Oh, that's something else. Or is.
What the hell?
Oh, fucking
does
Rust.
This make sense? Expected struct vec, found struct map.
We have errors even before that, so.
Oh, okay. That's less bad then.
So
the first error is expected reference, found string. So I need to put an apparently something like this.
Or maybe you need power. What?
Maybe this and parentheses. Maybe these and parentheses. Okay. Method cannot be called on string due to unsatisfied trait bounds.
Oh, you are using on dictionary, but is after
the
map.
I'm done. Sorry.
No. Wait, Lemus. There is no way a normal person No. Yeah. That is no way a normal person would cope with all this nesting, man.
Okay. Move occurs because of the value. A move occurs?
Mm-hmm. Yes.
Why the heck a move is happening? I'm not.
You
It's the
have
same
no.
guy. I'm
Wait.
just
Wait.
changing
Wait.
the
Wait.
same
Wait.
guy.
Wait. Wait. First of all, take a look on where they are.
Oh no! I see.
Mhm.
So I need to clone this, right? Which is rather sad.
I will not say that you need to clone it, but maybe that works.
Can I just request to own this?
Man,
Okay,
I
fine.
would prefer the clone because I think we can shoot on ourselves using the
Does
to own.
does Russ have garbage collection?
No, he doesn't.
Yeah,
That's
so
the
we
whole
are.
point.
I think that doing clones, we are basically leaking a bunch of memory, man.
No, no, man, no. You didn't
We are
get the
you.
point, Lemus.
No, we are. We are instead of clone because we're never gonna
No,
use this reference
that's
again.
no, Lemus. That's not leaking, man. Uh,
Wait, do you agree with me that if I do clone here, the dictionary still have a new another place in memory with the same content?
yes.
And you agree that I'm not freeing? I'm not
Yeah,
freeing
no.
anything.
I don't agree. We are freeing that. That's
Where?
the whole point about Rust. When the thing goes out of scope,
But I asked if it has garbage collection.
it doesn't. Wait, okay.
What's the name of this property then?
I think it's like linear types or something, but the way that they manage the memory, it's at compile time, they know when to allocate and when to free. They don't have runtime garbage collection. They know everything that they need to do at compile time. That's the whole point of Rust.
Nah, man, I think we are having a definition problem.
Okay. First of all, I agree with you that if we are cloning, then we are getting more space, right? We are allocating more stuff. But why are we not leaking? Because we are freeing. And why are we freeing? Because that's the whole point about Rust. He tracks when you allocate some memory that you will free only once. And
Yeah, so he
how?
does this.
No, man.
Exactly this the sentence. The automatic process of freeing up space in a computer's memory by removing data that is no longer required or in use.
Oh, okay.
This is exactly the definition.
Okay, Lemus. He doesn't have automatic garbage collection. In the sense that he's not on runtime, stopping everything, counting references, seeing if there are like references that are not being pointed to, and freeing that. They don't have that.
I don't know if garbage collection actually tells you when the collection is being done. Because you're talking about runtime versus compile time.
Oh man. Okay. Let me tell you how I think that things are done in other languages, and then you can say if I'm wrong. Probably am, at least in
No,
part.
I don't know. I don't know a bunch of about garbage collection.
Okay, but we can agree or not, right? After I say that to you.
Yeah.
I think the way they do is the following. Let's get JavaScript for instance. You can't allocate.
Why the heck you always use this example, man?
Okay, which language do you want? Java?
C++.
C++ is the same fucking thing. No, it's not.
It's not. It's just not.
You use free in C++?
Yes.
Yeah, then one that has like GC, like automatic garbage collection.
Haskell.
Okay, Haskell. Okay, let's see. The way he does is you can allocate stuff like at will. At will, you can allocate and use like things on the heap at will. You can just allocate and allocate at will. But how does he know when to free this? He can.
Oh, there's a book about that.
Okay, there's a book about that, but
which is Structure and Interpretation of Computer Programs, which is an awesome book. I recommend it. There they explain how functional. How can you, in a functional way, discover when something is not going to be used anymore?
Okay.
Which is pretty cool.
Okay, but let's use a case. Like, first of all, you have a lot of cases to do it. I think that language from Apple, they use something called reference counting.
Oh, Swift.
Yeah, Swift.
Okay.
Not many do, I guess. But usually, I think that in JavaScript they do that. They just see, they go through all the objects, the things that are allocated on a heap, and have references, and then they see, is someone pointing to that region of memory? If they are not, if it's like a dangling region of memory, then we just collect that. And that is done at runtime. You have to stop stuff and just go, imagine a for loop, go into all the objects and see, is someone pointing to that? If they are not, I can just get rid of that.
Yeah, that's basically how this book explains. So
Okay, but Rust doesn't do that. Why? Why he doesn't? Because at compile time, he knows when to do the free, not 0, not 2 or more, exactly 1 for each object. And how does he knows? When the variable that has the ownership of a region of memory goes out of scopes, then you free.
I see.
Then you can clone whatever. When goes out of scope, he will free. And sure, that happens at runtime, but he doesn't have the overhead of searching when you need, because you already know at compile time.
No, that's okay. I get it. Your point. Like I said, I think that you are going to the detail of when the automatic garbage collection is happening, which is important. I'm not saying it's not important. But I use garbage collection in a broader concept.
Like the free for you is also
if they are free for me and I don't have to think about it. Okay, I call that. Maybe I'm wrong. Maybe I'm naive and I don't know things, but I call that garbage collection for now.
Oh, okay. Well, I would think in this as like automatic garbage collection, like he. Oh wait, but Rust is also that, right? Because he's doing that. Like, just see that you are using free, but whatever. Let's just go clone or clone it. Let's. Oh, by the way, this is a rather interesting topic for you, maybe, Lemus. I don't think if it's called like a fine. How can I say that? Like, I'm not sure if it's called linear types or it's affinity types, something like that. But it's like a property that they will guarantee you that something occurs only once, and that that doesn't apply only to this situation. It's like a broader topic.
This should work fine. And then, but as you can see, we are almost done with the encoding.
Okay.
Like, it's really easier after getting the whole algorithm. You have your translation dictionary, man. You're close. You're close.
Yeah, I was searching here, and you can search for linear types if you want.
Okay, so I already forgot. We have 4 A's, so we need to have 4 1s. Then 4 B's, 4 couples of zeros, and then 3 C's, 3 0 1s. Nice! nice, man. Now, what we need to do is the following. Okay, so there's a gotcha that we need to pay attention to. And I'm going to explain to you right now what that is.
Okay.
Which is... just increase your volume here. Okay. So, for this is the header, okay? And this is the content.
Okay.
Every single one of these ones and every single zero here is actually a bit. So it's a bit. So it's being represented as a bit. Here is a string just for convenience.
Just because we like to do cursed stuff.
These guys are not all bits. The byte itself and the quantity of how many bits, these are bytes.
Okay.
So this is at 8 bits, 8 bits, 2 bits, 8 bits, 8 bits, 1 bit, 8, 8, and then we do like this. We
Oh my
always choose.
god, our representation is so messed up.
No, this is normal. This is normal.
Holy fuck.
This is how it's done. And why? You can ask why. Because this is because the byte, you cannot reduce the byte itself. Like the byte need to.
That's the thing, we don't know for sure. Like maybe they have data structures for representing like arbitrary number of bits. Like we don't know, right? But
No. I'm not talking about how we're gonna represent that in Rust. I'm talking about writing this into the final file.
oh, okay.
When you write this to the final file, we're not gonna write it like this.
You cannot get like half a space of memory, right?
Yeah. So this, because this is the key, right? This is the conversion of a key in this case a byte to a bit representation, and we don't know how many bits, right? Because we are only using 3 symbols, man. But this can go on and on and on, like with a bunch of different bytes. So this is why these 2 guys always are represented as a byte. We actually spent 8 bits on those 2.
Okay.
But here, this is not a byte. This is just a 0 and a 1. So what we do, and why I'm talking about this, because now we need to do the math for the padding. So for instance, we're gonna do a loop with all these guys, and we know that this is always the same order. It's always this, and this.
Okay.
We can even create a type for that if you want, like a struct.
What the? Oh, okay.
And then we're just gonna do 8 plus whatever is this. Actually, we can even drop this and just use the 2, right? So 8 bits for this, 8 bits for this. What is this? 2? Add 2. And then you're gonna go on and on and on. And after this, we're gonna have a final number of bits necessary to have the header. And then we're gonna have, this is easier because this is just summing up the length of each of these strings. And then you're gonna sum the first with the second, and this will provide us the number of how many bits we need to write into the file.
Okay.
But we need to do mod 8 on that to discover how many bits of padding we're gonna be adding to the end.
Okay.
And then that's it. That's the entire. That's the finishing. Encoding is all just this. Just the encoding.
Yeah, the first thing that I would ask is the thing about creating a struct is very good, because if you are not creating like I totally forgot the word for that. But like it's not uniform, you know? It's not an array of type A. They are all not the same thing.
Oh yeah, that's the thing. We are interpreting based on the position how they are represented.
Yeah, that's really error-prone.
Exactly. But this is how low level does. They don't care. Yeah. We care because we are not. We are trying to leverage the bar. Heap, struct, encode. So
and
instead of
at
doing
runtime is the same thing.
At runtime is the same. I agree. I'm not denying that.
No. I'm saying that for okay, we will do a better way in the programmer land, like in our program, but at runtime we don't have a cost for that. Well, not regarding the representation, right?
Yeah. Okay, so the symbol itself, man, this needs to be a U8. Because this is going to be a byte. And then the size of the bits. How many bits you're going to use? This is also U8. And then there's the problem, which is we don't have anything below U8 as far as I know.
Yeah, not that we know.
Because this should be like UT. Like something like this. But we don't have that, so this is probably going to be a string. And then the name of this will be header cell. Header. What do you think?
I think it's good.
Okay. And then this function right here, instead of returning a vector of this, we return a vector of header cells.
Okay.
And then we just need to do a let. So let head cell. And we're gonna do header cell.
That's also a map, right? But we already have the for in place.
This is also a map. Um, it is a map, but does the map of the hash map provide us both?
Good question. Well, you have the ether, right? So ether.map.
What is?
Yeah, like if it's like a tuple, you can also just do the struct part.
So symbol and bits. Is that what it? Yeah. Okay, this works. But this is ugly as hell. Can I break here? That would be cool. Okay, something like this. So let's sell, which will be a header cell, right? And then the first is the symbol. We're gonna have to own that, by the way, at some point to own it. And there's also what else? I already forgot. Size of bits. These will be bits.len dot to string. And then you also have bits, which will be, of course, bits.toOwned. And I think... And this can also now be just...
Hey, Lemus. I think I got it. What they mean by bit field. Man, imagine the following. You have a struct, okay? And you just say, oh, my struct will occupy 32 bits, okay? And then you just need that the fields from that struct sums up to that. Then they can be of arbitrary size, I guess.
Yeah.
No, but you see that would...
No, I'm following.
Yeah, that's what I'm reading here, but I'm not sure if I'm interpreting right. But that's what something that they are saying here. You know, maybe I'm interpreting wrong. But yeah, for what I understood, that would allow you to, okay, I have a field that this field has like 3 bits, right?
I see.
But the total structure would still have some specific size.
Yeah, the being bound to a specific size, man. Because this is why we need a padding, by the way.
No, yeah, but you see, that's a lot more efficient than using... Oh, okay, I need 2 bits and I use 1 byte for every time I need 2 bits. It's a lot more efficient. And it looks that they have this in C, this bit field thing.
Interesting. Okay, we'll do a vec of header because I don't want to have the map, and it's gonna be return of this apparently.
By the way, we need to do a C project sometime.
Oh, we will.
Do you have any idea, like, what kind of project?
Yes, I do, but I'm gonna share with you later.
Okay.
So, man, I do have a question about how the heck we. Okay, we don't need this. Is this right? Apparently no. Okay, so what am I doing?
Header, the ponto e vírgula after header cell.
Here, this guy.
Yeah.
Oh, okay. Okay, so the semicolon.
Oh, wait, just a moment. I guess my food arrived.
Okay. Expected weight found string. Oh, I forgot. We cannot do just like this. Oh, that sucks. String to U8.
Yeah, was actually not mine, but mine is coming.
Okay. Man, we need to convert the string to a U8. I forgot. Oh, as bytes.
Oh. Yeah,
Interesting.
but that's like a stream, right, of bytes. It's not one because doesn't make no sense.
Uh.
See?
No, but it's just one.
Yeah, that's why it doesn't make no sense. Okay.
So S. No.
Yeah, as bytes is not what you want, man. That will give you the byte that represents 0 and the byte that represents 1, like the char.
No, but that's fine because this is a
Really?
number.
Wait. Bits here, it's a string, right?
Yes.
Can you draw the literal for me there? What is inside bits?
Something along those lines.
Yeah, see. If you transform that in a vector of bytes, you get a vector of bytes.
No, but I don't want that. I'm
Yeah,
doing that dot
then...
len.
Oh, okay. Then you have the tree, and you want that as...
U8.
Yeah, you already have U size. You can do a conversion, but it's a dangerous one because the length of something is U size. It's like the word of the architecture you are using, I guess. They use it for size of stuff, right? For length. So you could convert that to a U8, but sure, it's something that could fail, right? You just need to know how to convert one number to a what's the opposite of bigger? A smaller one.
Smaller. Rust.
Okay.
No!
Commander. Can you explain what we are building for people that are here?
Yeah, we are... Okay, no. It depends on how far you want me to explain.
From the beginning. No, you don't need to go like step by step. Just what we are doing, like building. What is the
Right.
Ruffman?
Oh, the Ruffman is a compression algorithm with no losses that is usually pretty good at compressing text in natural language. And it's based on trees. And it's a pretty good exercise to low-level programming languages. That's what we are doing.
That's a good description, man.
So this is basically the algorithm by itself. So this is how you have this, and then and you want to going from 1 to 8, you end up with this, and this has less bits than these because each of these letters or characters they are occupying 8 bits. So our goal is to basically transform this into this and do the reverse process. So then when you're sharing your text with whatever, like maybe it's like Google Drive or a person, you don't want the text to be ginormous, right? And then you can just zip. This is actually the foundation of the zip, by the way. A lot of like compressors like WinRAR, 7-zip, they do have Huffman in them. So we are basically, of course, the Huffman is pretty simple. It's not the most the percentage of compression is not the highest, but it's not too complicated to implement. And because I don't know Rust, I think it's a good candidate for me to learn, and that's what we're doing. So I'm gonna try to do the from here.
Oh, okay. We have the S, right? I don't, not really sure what A is. Oh, okay. You are trying to print with the debug, but he doesn't have it. You have to derive the debug.
Oh, okay. We need to just copy paste it from this guy.
By the way, is it? Yeah, it's called derived. Yeah. Do you need comparison though?
Don't care.
Okay. Hey, but I think you have a line there between the.
Have what? Sorry.
I think you have a line there.
Oh no, you can't figure out the
like the 7 you. Line 7. I think you can get rid of line 7.
Oh, here.
Uh-huh.
I think it doesn't matter though.
Okay.
Ugh. Okay,
Oh.
expected U8 found the string. Uh, oh, this is the same thing. This is the same. U8 from okay. Is not implemented for U8. What the heck are you talking?
Okay, Lemus, Commander is asking, how do we choose the languages for our projects?
We kind of have an election process because we have a list of languages that some of us are interested in learning, and we have a list of projects that we grabbed from the internet. So we first vote about which language, and I usually try to add some suggestions of projects. So, for instance, the Tetris in Lisp, that was a suggestion that Magete and I composed for the Lisp candidate. And after deciding the language, we decide the project. And this time, and maybe we're going to decide for the suggestion, maybe not. And this is as far as I'm planning, right? Because I am responsible for this part. This is how I'm planning to continue doing the elections for now.
One thing in common that we have is someone is learning something from it, right?
Yeah, we have a really we found learning as a like a pleasure for us. If you want to know more about it, in the Discord server, we have a chat called Info. I explain all of that in the Info channel with go into more detail. So apparently the string doesn't have a from, whatever the heck is that. I don't know how that's possible because bits is also string. Oh, but this is a number. This is a U size. Uh,
Yeah,
okay.
try to go like the S, like SU8, like you want like bits.length space S space U8 to see if that.
No, this worked.
Oh, okay, I see.
This one didn't work.
Oh. Yeah, because we are trying to do is symbol string there? It is, right? Yeah, is string
Yeah.
to U8 make no sense.
It should be the representation, right?
No, man.
The bit representation.
No, wait. Like, you have a vector of chars, right? That's what you have. And the char can be a U8.
No. I understand that, but we that's not the case because when we made the encoding, we did the opposite. So we have a U8 and we transform it to a string.
Yeah.
But I assure you that this is the way back. Like we have the string. We want to go back to this.
Oh, hey, I know it, man. We have the parse for everything. Try to use
What?
Try to do dot parse, I guess, in the string. Is it dot parse? I forgot, but we have a parse one that get its string to the type that you want.
Symbol dot parse. Okay, that's parse apparently.
And that's
what this parse does?
Well, he will parse for the type that you want.
That seems too good to be true. I'm not. I don't know if I believe it. Okay, so parse apparently returns result.
Sure, because it can fail, right?
Okay, that's adding shells now. It's kind of complicated.
No, you just do an unwrap.
Okay, sure.
Just don't deal with it, and you don't need it to one, man.
I think I do, man.
I'll try without it.
Because this will be considered a move, I think. I'm not, man. My music's too low. Okay. No. Okay, so now this is broken.
What?
But this was working.
Yeah, that's what the
fuck? Interesting. Rather interesting. Okay, so from U size, you cannot go from a U size to a U8, apparently.
No, no,
which is
no. You certainly can in a new safe way, but you have a way. Try the S.
oh, so bits.len.s.
Yeah. No, no,
I
not
don't
dot
think I have.
S. No, no, just space S and the type that you want, and you could like delete the U8 from.
Oh man, if you finish the encoding today, I would be so happy because we are so close. I think it worked. Nice.
But
That's nice.
yeah,
But it converted it back to the number. I don't know if I like this. Because this is not like we want the letter C here. Like the byte
no, no,
of
no,
the
no, no.
C.
That's easy. That's easy, right? That's easy. U8 to char is easy.
Can't we do just symbol as byte or as U8? No, this as byte.
No, no, is string to that? I don't think so.
No, because if we
Wait,
do
as byte?
like
What do you mean by byte? You mean like
no,
U8,
let me
right?
explain. Let me explain. So when we did the inverse, like the beginning of the process, we pick a U8 and translated that to a string, just because it was easy to manipulate. But then we want to have the opposite. We have a string, but we know it fits in a
Wait,
U8.
wait, wait, wait. Go back to your terminal. You are saying that there, where you have like symbol 99, you would like the bit representation of that?
No, I would like to have like I don't know in Python bytes are represented with like B, like I don't know C. This is in Python. I think this is the way that bytes are the byte C, the byte of the character C is represented.
But that doesn't matter, right?
It kind of doesn't. It kind of doesn't because the bit representation I think will be the same.
Yeah, like
So it kind of doesn't, but I'm still bothered by it.
okay, you would be better for visualization, right?
Yeah.
Um.
But I don't want us to lose time on that because we have. I don't
Okay.
want to go that much beyond 20 minutes.
Mhm.
Okay, so now we just do sum. We do a. Oh, this is a fold, right? This is a fold,
Sure.
and this is also a fold. And then we sum the folds. The folds. Nice. Um, nice.
You want to do a
So
fold of summing the length of the item, right?
yeah, we're gonna do in the header cell. We're gonna do 8 plus the length of this, and then this is the fold for all this list here.
Oh,
All
okay,
this,
okay, I see. Yeah, two
and
folds, one for the header. Yeah.
this fold of the content will be a fold in which you're gonna sum the lengths of this,
Okay, I see.
and then this will tells us how much bits of padding.
Oh, okay.
So
Now I have my idea. Now.
okay, so which file I will put this? I think it's more related to I/O because it's related to how we're gonna write the padding. So I'm gonna put it here for now. Get padding bits. We're gonna skip. Oh, Commander, I don't know if you're watching, but if you are, Mageta will love Lisp lessons. He is the most Lisp enthusiast here. Person. The most enthusiast person with Lisp ever. Um, so this will return what exactly? This will return a number, right? As far as I know. How do we do a number? Int? So we need um wait. Okay, we need this. So this will be the header itself. And we also need the content, the mapped content, which I believe I have it down here. Vec of string, which is fine. Okay. So how we gonna do this? It's gonna be let header
Okay, I'm back.
bit size. It's gonna be header iter. Do we need to? I think we need to transform to an iter to do a fold, right?
I think so.
Okay. Are you? Oh yes. Okay, it's here. So the init value is gonna be 0, and the function will be. We're gonna pick a cell, and I'm not entirely sure.
Don't you need the accumulator somewhere? Like, oh,
No, no,
okay,
the
there,
accumulator is in the
there,
init.
right? No,
Yeah,
on the F. Like
on the
F,
F.
you are receiving accumulator and the current one.
I am receiving the accumulator.
Well, you need that. Well, on the F is the function, right? It
Yes,
should
it's
be
a
of a
function that
function of
picks.
two
Oh,
arguments.
it picks B. It picks B. So this is the accumulator. So this will be this accumulator equals accumulator. Can we just do
Wait,
plus equal?
no, what the fuck are you doing?
It's gonna be
No,
8
no equal though.
8
No equal though.
plus.
It's
Let me just
just
try. Let me
plus.
just try. Cell dot.
No,
Uh,
wait, Lemos. The next iteration, the accumulator will be what you are returning. You don't need mutation there.
oh, so I just do placeholder in here. Is that? Do we have placeholder in here?
No. What are you doing, man? What is that? No. Wait. Just put ACC there and just delete the equals. Yeah. That's it.
Okay. Okay. So this should be the header bit size, and then we're gonna have the content bit size, which will be mapped.
Can you hear me?
Yeah, but your microphone is bad.
Oh. Is it better now? Okay, because I stumbled on the cable.
Okay, so you're gonna have an accumulator, you're gonna have bits, and this will be accumulator plus bits land. And then we're gonna be using mod, mods in Rust, mod operator.
It will be probably like dot mod. Wait, but what mod do you want?
Exactly the one that usually use.
In which language? We have different modules.
C, Python, Haskell.
Okay. Then I guess you have the same symbol, the percentage one.
No, nice. Okay, we're gonna return header size, bit size, plus content bit size, and mod 8. And this should be enough. Okay.
And wait, don't you need the result of the mod? And then don't you need like 8 minus the result of this mod? To know how much padding?
No.
Because like isn't the result of the mod how much you have passed? Like the 8 barrier?
No, it's the reminder of the division.
Wait a
And the
second.
reminder of the division is exactly what we need to add to the half the multiple of 8. But we have a problem because of use sizes and whatever you have. I just need to do S, I think.
No, Lems, I think you are wrong, man. Like, give like a piece of a lot of things, and then you divide by 8. The remainder, it's like, okay, you have that, and plus something.
Yeah, no, you're right. Just done.
Okay.
17 divided by 8, the remainder is 1. And adding 1 to the 17.
Oh, okay. Yeah, it's 8 plus 8 minus this thing, right?
Yes.
Hey, man, precedence. Maybe we are doing a really shitty thing. We don't know the precedence of minus and the module operator. But not on the module, right?
You're talking about adding a new set.
Okay, let's go.
Okay, so can we have an example? Print and I did this in IoT. Okay, so that means need to pass to it the factor of the get dictionary. Are we using the get dictionary? Okay, we need to call this first. Okay, listen up. Get dict. It's probably going to do IO code. This code is called get. No, it's IO, right? Get dictionary. And we pass to it the bit representation, which is this guy. This is to be mutable. Nice. And then we keep this vector, and we also need the content already translated, which is mapped to it. So map. We need the content. Oh no, I already have this. It's translated. The order I already got is the vector and then the content. Let me change almost there. We're close. Maybe gonna stretch a little bit of the time, not so much. It's retaining the number 8, which is rather interesting, because I think that's wrong. It doesn't make sense. Oh!
Did we check it? This range? If it's working the way we want? Like, because n.
Later?
Man, I think we need a -1 on this n.
Oh, you think so?
Yeah, because it's zero indexed, right?
Okay, so we have 8 plus 8 plus 2 plus 8 plus 8 plus 2 again plus 8 plus 8 plus 1. Okay, so the size of the header is 53 bits. And then we have 1, 2, 3, 4, 5, 7, 9, 11, 13, 15, 17, 19. So it's this. 53 plus 19. So this is 72. Oh, this is exactly the same. Like this is a multiple of 8, right? Am I wrong?
I don't know.
Yeah, this is a multiple of 8.
Sus.
This is a multiple of 8. Which means
Yeah, that's 9 times 8, yeah.
this should be 0.
Oh, that music is really good, man. Hey, but mate, I think our range may be wrong. I think we are off by 1 there.
Off by 1? No, man, that doesn't make sense.
No, see, like,
Oh, it's because this is 0.
no, wait, I'm talking about line 41. Mm-hmm.
But this... What are you talking about?
0 to n minus 4. Isn't supposed to be n minus 1 minus 4? Because
No, man, this is the file name. has nothing to do what we were doing. This is picking the text
Okay.
.txt and making it test, and then adding test dot
Oh, okay. Doesn't matter. Yeah, doesn't matter for anything. Yeah. Okay,
This is
let's.
a hungry knuckle. This what happened.
By the way, I only have ate like 3 bananas today, like on the morning.
Yeah, but we need to check this. If this is 0, we should not do this math.
Mm.
If so, let reminder. And we pick this, which is fine. And if reminder, in Rust is only 1 equal or 2 equals?
I don't know.
Uh,
See a if that we have.
no, it's 2.
Oh, okay.
If this is actually, does this work? What happens if you do not Huffman Algorithm?
Man, no, that's not JavaScript.
No, but this is C.
Oh, okay. I see. But no, doesn't work.
Then we return 0. Else return 8 minus.
Mm.
Which is okay. Okay, so theoretically this should be 0 now instead of 8. Nice. Now we have all the pieces.
Oh man.
Finally have the final formula. So inside the Enconding IO, we have compress file. This is where we're gonna call all the functions. Which things we need? Oh, we need the file command. Oh, we already have the file command, so we don't need to have. File. I don't know. Type. Mutated vector 8. Vector 8. Which is better fine. So let mute map. Let me just copy paste. It's easy. Just copy paste all of this. It's fine. It's fine. Encode map create. File presentation. And then we have the header set, which is basically that. And now we're gonna have the padding thing, right? This guy. And now, my friends, we just have to write a file.
Now let's see how to do that. It's probably the IO thing that we already have.
I guess so. No, file create.
How to open a file? Oh my god, man.
So we need this guy. Let's call this compressed file. And the path instead of this will be new file name. How to write? Write on. What is this being?
That's byte, I guess. Wait. No, but the byte that I was thinking about is regarding, like you give it a shard. I don't know. I actually not sure.
Interesting. I don't know. I want to see the type signature. Right. What is this? Pizza buff of which is a reference to a vector of 2 bits. flat a vector?
Probably, yes.
We need to do that. Flat a vector Rust.
You could do that with the fold if they don't have flatten.
That would be. I would be sad.
So take a look if you don't have the dot flatten.
Okay. So let's do translated content dot. Oh, it needs to precedent type. So are you happy now? No. Okay. So I'm out of it's not working. Yeah, I'm out of it. It's broken for some reason. Just rather consider list. String. I don't think we need that. Why is this not working?
I think that maybe my sound is bad. Like the commander is saying.
You're too loud, maybe?
No. He said that now he can barely hear one of us. It's probably me, right? Because you are fine here.
Yeah, you control the audio. Okay, so you can flatten.
You can? Nice!
Yeah, I guess. Oh, this is exactly what I want. This example with the string, see?
Uh-huh.
Is exactly what I want. But I need to do collected in as well for some reason. What collected does? Let mute.
I think it goes from a ether to a collection, but I'm not sure.
Man, we have a let mute beats. We need to do a map, a second map. Yeah, we actually do need that. So get dictionary header. This is the site I use. This is here. Okay, so this is a vector of head subs. Okay. You're muted, Mama.
Yeah, it's because I'm eating, and also if my audio is really bad, then it's not really a good idea to talk.
But if your audio is bad, maybe mine as well, because you are the one controlling the volume.
I'm not sure if that's the case.
Just see if commanders.
Wait.
That's fine. A map. Yes, that's what we want. A map will be composed of a cell, and we want to do that as a collection as well. So what are we gonna be doing here? We're gonna pick a cell, pick the symbol. How do you transform a number to a bit? Okay, there's a binary, apparently. No, I don't want to format it. I don't want to format. Yeah, I don't want to format. I want to convert it. How I do it?
He's saying that is the problem is your audio. He's saying that you is too quiet, but it makes no
No, you
sense.
just need to increase my volume.
That's weird because I can clearly hear you. And you are on the maximum.
Okay, so go to OBS and change there.
You also are on the maximum, like that's desktop audio.
Yeah, okay, so I lost the ideas. I'm out of ideas now.
What do you mean? For printing?
No, I just want to convert the number 99 to its bit representation.
Wait. You have a U8 that is 99,
No, I have a EI32, I guess.
and you want to see its representation because it doesn't make sense to
No, I don't want to
convert.
see. I want to have.
So what you are saying doesn't make any sense, Lemus. He already is the bit representation that you are wanting.
What happens if I do toString on here?
It will be the number, not the bit representation.
I don't want the number.
You want the string of the bit representation?
Yes.
So then it's probably some kind of formatting, man.
If I have a U8 and I do dot string, what happens?
You will get the... For instance, if you have like 99, you will get the string 99. Even if the representation it's like zeros and ones, you will not get that.
Oh, so then we are screwed.
Not really.
We are.
I know that we can print the bit representation, but how to get the string from that?
Okay, I know how. I was not thinking about doing like that. It's fine. So let's do string and then for cell in header cells, I will do bits push. This is not what I want. I don't want string, I want bytes. I want something like bytes. Can I have that? What is this? We have push. Those are bytes. Okay, bytes in Rust.
Oh, okay. So that notation, I guess it was for a vector of like bytes. Bytes, like the individual char.
Is that how we do it? We're so close to finishing the code. Okay, so what are the functions of these bytes? Oh, I need to see the capacity? Are you joking? Let's say that you're joking.
Yeah, if that's the case, then it's not the vector.
No, we want to have... It's because in the example of writing to the file, you see that what he's doing is picking a string and then converting to using this.
Okay.
I want to do the same thing with ones and zeros. But apparently that is not a thing. So what I want to do now is to just have like a string of bytes and then just write it all. See?
I see, but did you saw the signature of write-out? Isn't that a vector of U8s?
It is a vector of U8s.
Then we already have what we need, right?
It's gonna be complicated with these two other guys, but let's just start with that. So we have a vector of U8. What is this? New. And here I will put vec of U8. And then for each of this is push or insert for the vector. I assume it's push. We're gonna be doing cell dot symbol. Then we're gonna push cell dot size of bits. And then there's a problem. Because we don't have a U8 at this moment in time. You see that? We have only like 0, 0. We have this. We have 8 bits, and then 2 bits.
Okay.
You understand?
Okay, yes.
This is why I wanted to go with the string approach. Because if we lock ourselves to a vector of U8s, then how the heck are we gonna write 2 bits?
I know how. I know how. Knowing the size of bits, you can do mask stuff.
No. That's just a ping. That's just
Huh?
for ping.
I
Yeah,
don't.
the decoding process will have to do the unmasking. Like, remember, we are writing something that you're gonna have to read in the next session.
No. I'm saying what you want is 0, 0, and then padding to give it a byte, right?
No, I don't want that.
Oh. So.
I want 8 bits, 2 bits. That's what I want.
Only 2 bits? Okay, see.
Only 2. So this is why I wanted to go with the string approach. Because then, if you convert this to a binary and then to a string, then we are fine. You see? So this is why I was searching about byte stuff. Because, well, get binary representation.
Like, also for writing, like you can just, how can I say? You can only write in bytes.
No, you're not understanding. How I did this in Python. Back in the day, I created a ginormous string with ones and zeros.
Okay.
So instead of dealing with bytes themselves and bits, we only have a really long string of ones and zeros. And then I founded a function in some Python library that picks all these ones and zeros in a string and interprets them as bits.
Okay.
So I just manipulating bits is only manipulating strings. So this is what I'm attempting to do.
Yeah, but going from strings to bits, probably will not find outside a crate, a library.
No, we can try to find a library offline. That's not a problem. We just want to have something like at least the string, the ginormous string I want to have. Decimal to binary inverse. This is exactly. This is pretty close to where I want. Why? Is this works as I think this? What about putting form inside? Inside of values, maybe cell. Instead of this, size of this. But for now, this is enough.
Okay. Wait, what is that? You have a question mark there.
Where?
Line 68.
This is because I copy pasted from the respect.
Okay.
So just pick this. Where the heck is this not compiling? Oh, it's because I'm complaining about file content. So file contents. This is also. Oh, and I can probably use some other things. It's fine. Let's print this guy. So can you print bits? This is nice. Expected a U8 found string.
That's because you're off formatted there, isn't it? No, I don't.
Oh, I know, right?
Oh, bits dot.
Frame.
Oh, okay. Bits dot push.
Okay. Expected char. Found struct. flatten them. Okay, that's fine. So new will be effect of strings. Then we flatten them.
Okay.
My music is again low. Not founding IO. Which means that we are missing some imports. Well, which is true. This. It's complaining about what.
Maybe
Oh,
you are.
this is the model IO. I'm including the thing in 20.
Oh.
Okay, so this is complaining in. Oh, it's because you don't need to the reference. We are already in this module. Which is fine. Okay, so use of undeclared crate or module bytes. It's because I was trying to be a hero. Work. Okay. Now.
Cannot borrow.
Warn unused parents.
No, that's just warnings. You can go down there. Like, cannot borrow.
Bit representation is mutable, as it is not declared as mutable. What are you talking about?
What is bit representation?
It is mutable. What the heck are you talking about?
Okay, where are you? Ah.
Get dictionary header is in here, and this is
No, wait, but there is a hash map. But get dictionary header, you are passing that hash map?
Yes, here.
Wait,
It's talking about.
let header cells. What is that?
It's here, man. Here.
Okay, let's take a look on this. It makes no sense for me.
I'm really confused.
Wait, maybe you don't need this emute because he already is? Try,
This is what?
because he already is, maybe. Try to use just bit representation.
Are you sure?
I have no idea, just trying.
Oh yeah.
Okay.
Okay, so what's the bit representation of 98? One, three zeros, 1, 0. Yeah, this is correct.
Okay.
And this is the number 2. Oh, this is a problem.
Hmm?
Yeah.
Oh, there you want the... Wait.
This is the number 2. But we need it to occupy 8 bits, this particular case. So, how are we gonna do this?
It's because... Why are you doing this conversion?
Here.
Okay, what is cell symbol there?
This is U8.
You wait. Oh.
No, but this is right. This is this.
Oh, okay, wait. I mean, the two.
Yeah, the 2 is also a U8, but it's using the minimal representation. I don't want the minimal. I always want.
Oh, yeah, it's probably something that you can put on the format to, like, occupy at least 8.
Yeah, I also do this. How?
Oh, wait. There. Go down a little bit. Yeah, there. Wait. See on format. Like, the last one. The last one that you will find.
Minus 16.
No. The last one of your screen right now.
Oh, here.
Yeah, see the L? Something? Like, this L. Like, something there.
Maybe length. L for length.
Like, there is a variable. There is a variable. You actually have a L there in that code. No. Wait, take a look on the code that you copied this from. Like, see?
Oh, L is here.
Yeah.
Okay, let's try this notation.
Oh.
Expected format
What?
Maybe the hashtag is not the one that we want. Is that possible?
Ah. Oh, do you have the column?
The column?
Did you delete the column?
No.
Yeah, you delete the column. Like, put a column before the hashtag.
Oh, like this?
Yeah, let's try it.
Oh, okay, sorry.
Ah!
No.
Oh, wait, I'm pretty sure we can fix this. Go back there. Like, the number is correct, right? We...
Oh, she removed the beat?
I have no idea.
Uh,
Maybe it's the hashtag?
maybe it's the hashtag you think.
Yeah, because I think you need the B.
I think you need the B. Yeah, we need the B.
Okay, put the B and delete the hashtag. Oh man.
This is where low-level stuff starts to piss me off. Now it's
Hmm.
correct. Now it's correct. Now we just need to flat this. Which is fine, I guess. Because we just need to do like bits dot inter dot flatten and dot collect. I hope this is mutating the bits.
I don't think so.
I hope.
I don't think so.
You don't think so?
Yeah. Like.
What am I gonna call this? Nether bits?
The naming the hardest part.
And naming is the worst. Naming is complicated.
Oh, by the way, we are already like past like 20 minutes.
No, I know, but we are almost done.
Okay.
Nether.
I will just get something then, like milkshake.
Next step. The translated is already, so this should be fine. And the padding is just a number, which also should be fine.
I'm back.
We are almost done here, bud.
Okay.
I would do the writing to a file automatically.
Okay, what is this bits again?
Bits is the final.
No, the type.
Oh, the type is gonna be a string.
Okay.
This is a string. After this we print. No, not after this. No, it is a string. So what we are doing here? We are picking the padding. We actually so this will be dot push and we format 8b this parenthesis and instead of cell.symbol it's going to be padding. I think this should be it. I hope. Please work. It will not work.
Oh man.
Okay, so this is not a string. Okay, so now I'm really confused. What is your type?
Man, did you read what collection does?
Not until now. Iterate bounds. Oh, string is not an iterator. No, but oh no, this is not. Oh, here. String is not an iterator, but header bits is not a string, my man. Header bits. Header bits should be a vector of strings. So I am picking the vector, and then I'm iterating on it, and then I'm flattening. And I'm flattening, and then I'm collecting to get back to the other type. Which is kind of like, it's fine, but let me just see if this works. This does not. String is not an iterator. Okay, so something really weird is going on.
The dot iter is not working, like...
No, it's assuming that this is a string.
Okay, no. Man, take a look. You are itering a vec of strings. So, you have a string. And then you are flattened. Oh, I see. Yeah, this is wrong. This is wrong. You don't have a vector of vectors of strings. What you want is a vector of strings to a string that's not flattened.
So this is actually a string. And we are pushing it. So these lines should just disappear.
Push receives a shard. You need like either push str or just the concatenate or something like that.
You had a good idea. Does str. And you just yield it. str.
He's complaining already.
What is the format function? Oh, it's because we need to convert this to str. Okay. This is promising. So now we remove these.
Oh man, this was a fight to get working. Holy fuck.
Please work. Of course not. Failed to resolve. Use an undeclared creator module. Okay, so I'm using something with the encode module. So module encode. Oops. Is that how you do it? Yeah. Why you are complaining?
Don't you have circular dependencies there?
Probably. No, we don't.
Huh.
We don't have circular dependencies. Yeah, it's still complaining. I cannot find module.
Oh, here, yeah, that's the thing about Rust. That's the thing. You see where he's looking for?
Why?
No, that's how.
Why?
Man, the module system in Rust, it's not the best in my opinion.
How can we import this?
Man, I would abide with what he's saying. Wait, not sure though, because you need encoding main, right?
Yeah, and in main we are importing just fine. Why is this working then?
Wait, go to IO.
Maybe it's the order? No, it's not the order. Cannot find module. Okay, this is Rust Analyzer complaining. Let me just try this. Yeah, not found. Yeah, because we don't find a module.
Like, if you want to spend the time, I have the page that explain the module system.
Let me try something first.
Oh, okay, there they have the path.
Why people do this? Like, why? Okay, so there's a way to overwrite the module. How this module is trying to find.
This is so bad.
Jeez.
Oh man.
Why people do things like this?
We are doing a bunch of workaround. No, but that's like workaround, Lemos. We are doing shit, you know that.
Error. String is on an iterator. String is on an iterator. What are you talking?
The flatten.
Translated content is an iterator.
No, wait. Man, the flatten only works if you have a vac of strings.
If I have a vector of strings and I want to flatten all the strings in one, what do I do?
You don't do a flatten. You have to sum up those strings like a fold.
Yeah, but there is I found a flatten.
Man, the types of flatten, it's like a list for a list. Oh, see the type there.
Into iter.
What the? No. Look the type there. Vac t for vac t.
Yeah, I see. Okay, so we need to do a fold because whatever. Okay, that's fine. We can do a fold. This.
Maybe you would prefer a for.
No, it's fine. It's a function that picks the accumulator.
String.new.
String.
The init.
String.new.
Yep.
Dot.
No, yeah. This one.
I don't think that's right. Anyway. You're gonna do accumulator plus str. I'm guessing this is wrong.
Oh, okay. I see. Yeah, I think we need a for.
No. Don't. We are the movement against force. Okay, so there's a problem because they do not overload this damn thing. Okay. You accept that. So push as str,
Oh my god.
I guess. This is also as str. Method not found in this.
Yeah, because you are initiating the string as like not the actual string, just a slice.
What? No, this is the type that I want, right?
Yeah, no, not really. This one doesn't have. This is an array. It's a static array. They call this a slice. That doesn't have push because it's fixed. You would want the string new because he can do that. But even so, I think that will be wrong because you are doing push on the accumulator. That's weird. Man,
No, it's because the plus operation in strings is push. This is the same thing as doing plus. It's just a different notation. If they use push, whatever.
no, it's not quite the same. You are mutating the ACC instead of returning that. Yeah, but maybe you could push and then return the ACC, right?
Yeah. Let's try that first.
No, but you need the string new if you are going to use the push.
I don't think that's gonna work.
And then after push, you do like you need a block. You block there.
Block where? Here?
The block the body of this function. You need more than one line.
Oh, so like this.
Yeah, because I think you need to push and then return ACC. Yeah, he's complaining about the new.
Yes. Expected this from this. So it is empty.
Yeah, but doing that way, we don't have the push. Then I think we need to use a for, man. Oh, you man, and you already have the beats there, so you just do a for on translated contents, and inside that you just sum up the beats with the current one. Don't you need the ether? Yeah. Maybe you don't. What is he complaining about there?
Something about
Mm.
now he's complaining about something else. The not borrow file content.
Oh, I think it's the same problem, maybe.
Yeah, same problem. Which is rather weird.
Mm-mm.
Can you explain why you don't find this weird?
Because
It's
is it
already notated here.
is already a reference, so you would be passing a reference of a reference.
Okay, this worked. Now last part. Then. This should be easy as fuck. It's just a matter of like pushing this. This should be it. But because you return a very fancy whatever. Let's complain about
By the way, he's telling you to remove parentheses somewhere as a warning.
oh yeah, no, a classic. Classic.
No, no.
There's no problem.
Okay.
This is actually not that does not comes here.
Hmm.
The translated content is the final one.
Lemos, you really have to take a minute and take a look on the precedence table for the languages you are using, man.
I don't think so.
You just put parentheses everywhere.
For index and range. This is this work.
Mm. Not found in scope.
How you do range? I already forgot.
Oh, okay, it's the 0 dot dot.
Oh, this is Python.
Yeah, but I think we need the equal if you want to include the last one.
I don't want the last one.
Okay.
Not found in scope. Are you sure?
Mm. Mm-mm-mm. You don't need the function range, like the notation 0 dot dot padding is already range.
Oh. And there's a problem here as well. It's complaining that this is too problem. Okay, so we have the padding, we add the padding, then we put the content, just the content, and then we put the padding itself, which is fine, I guess. Okay, so now it's complaining about use of move value header cells. What the heck are you talking about?
You move it to another variable and then you're trying to use it.
I moved to a different,
Yeah.
so I need to clone this one.
No, maybe not necessarily. You could you could pass a reference to it. Just borrowing. Borrowing. That's a hard word.
First error. Add cells has type with design commands. No, it's still complaining about the same value borrowed here after moving. What do you mean the hard?
Oh, so what is moving that? He said that was the intuiter?
Yeah, he said it's this. This is the problem.
No. This is you using after you move it. But where are you moving? Right?
Is this considered to be moving, iterating through a for?
No.
So yeah, I don't know exactly where I'm moving.
Okay. Header cells.
I know.
Okay.
The internal contents of the header cells, I'm moving them to bits. Which means
I don't know. What means that too?
Method cannot be called due to unspecified trait bounds. Oh, it needs to be cloned. Which is
Yeah, needs to implement clone.
fine. But do you agree with my analysis? Am I moving the contents of the header cells?
I don't think so. I don't think so. Because what you are actually pushing is the slice. You are only using that to the format, and I don't think the format is taking the ownership.
I think so.
But you can clone there if you want to, like cell.symbol.clone to guarantee.
And that's user commands.
Wait, but it's not that we're talking about. We're talking about the header cells, right?
No, but it's inside.
Oh, okay, see. Wait, maybe. Oh, try to change to .ether if this thing doesn't work. Okay, let's try the .ether. I think that's.
Remove the clones?
Yeah. That will be interesting. Because the .ether, because the .ether.
I need you to dereference these guys now.
No, they have a bunch of automatic dereference in a bunch of places, Lemus.
That makes the language really confusing.
It depends.
No, it not depends. This is an address. Why the heck? Sometimes it differentiates the reference from me by itself. What the heck's going on?
We still have, right?
Yeah, but now we have this.
Do we?
Move because which is unimplemented.
Oh, translated content. Go there.
Translated content line 65.
It's also .ether. No, but
I don't think it's that.
wait. Translated content.
Oh, it is. Let's try to.
No. But we are already moving. Like before that, like see the get padding bits. You are moving the translated content.
No, it's not muted. It's not mutated.
No. Go down. See the function like get padding bits.
Yes.
See that you are passing the translated content, not as a reference.
Yes.
So you are moving.
Oh, makes sense.
Oh.
43 minutes late.
Oh my god.
Worked. Okay, final test. Give me dot.
Oh yeah, Commander is saying that same thing that I was saying in the previous sessions, man, for you to do the cargo check. But you had a bad experience with it, right?
This is wrong.
Oh no. Oh no.
I'm so sad. I'm so
We are doing something wrong somewhere.
Yeah, it's really wrong. It's not even the padding is working. This is having no zeros, extra zeros, which is fine.
Wait, are you sure that... Are you sure that our range is working in this 0 dot dot padding? Like, are we iterating the...
No, I added the print here. So the first 75 is before this 4.
No, I mean... how can I say, man? Like, do a print inside the 4.
Right.
Because I want to see how many times are we going to this thing. To this... No, wait. In this specific situation?
Yeah, in this specific situation.
Oh, okay, I see.
Because we have 72 bytes. So 72 bits. So something is really wrong.
Oh, and it's not the padding, right?
It's not the
Oh, wait, the formatting. Were all of those supposed to have 8 bits? Line like...
Yeah, the symbol itself, yes. And then oh, this is wrong. This is just wrong. Because here we just, instead of doing... We forgot to add the bits themselves.
Oh, okay.
So this is going to be cell.bits. Is that it?
No, we still need format, right?
No, we don't. This is the guy that we remember. We want just 2 bits. This is the 2 bits.
Wait, but this is a string, right? No, you need to format, Lemos. Wait, no, bits is already a string?
Yes.
Oh, okay, yeah, you're right. It's just because we need the SSTR, right?
Yes. I think
You think?
yeah, oh, this is correct. Because we have 72 bits of content and 8 bits of padding to inform how many bits of padding.
Wait, doesn't make sense to have 8 bits of padding.
You,
You...
I didn't do that. I think when I did it, I decided to go with 8 because it's just like, okay, I'm wasting a few bits here and there, whatever the crap.
No, I mean, if you are doing a padding of 8, it's just not padding.
No, you didn't get it.
Okay.
The extra 8 bits are informing how many bits at the end are padding.
Okay.
Let me go to the drawing. Okay, so this, we have the dictionary. And how many bits? How many bits
Uh-huh.
are padding? In this particular case, it's 0.
Oh, okay, I see. And then you don't have... Oh, I see.
And then we add the padding in this loop here.
That is nothing, because it's saying 0, right? Okay, I see.
And then...
Now we need to test something with padding.
Yeah, we do. Actually, it was a total coincidence that this does not require padding. You do write these to a file. Okay, we're done. Finally.
Oh man,
Oh, Jesus.
this was tough.
One session for encoding, and the next session, because I will do this offline, we're gonna do decoding.
Lemos. But man, I think we have to be less... I forgot the name. But we need to like say that it's okay to make a session and we don't progress as much as we want because we are taking too much time in a session, man.
No, I actually didn't. I was not expecting to be 48 minutes late. I was expecting something like 10 to 15. So that was my bad. Okay. Okay, this is fine. I will push this into the record.
Okay.
This is fine, just fine.
Okay, so I will end the stream, okay?
Yeah.
So bye bye folks. Thanks for showing up. and bye bye.